Welcome back to another episode in my Learning Integration series. This lesson will be focusing on integration by substitution, focusing on the ln of x function. Okay, so here we have our function equals ln of x and the integral, which is x ln of x minus x plus c. Now, you can use integration methods to solve that and prove that, but I'm going to make a separate video on that, and I'm going to show you other methods of substitution. Anyway, let's start with our first example. Example 1. Okay, here we have our function equals cos x multiplied by ln of sine x. Now, for rules of just integrate and find the integral, you pick, is it a function times a function? Yes. Inside one of these functions, if you derive that in a function, could you get something that could help eliminate this? Yes. Therefore, we use substitution. If the answer was no, you would try by parts. But we can do it substitution, so we're going to. First step, find the integral of both sides. Capital F to signify the integral. And use the integrand cos x ln sine x dx. Okay. Anything in between the integrand and dx, we're finding the integral of. Now we've got to pick something to sub. We suggested that if we derive sine x, we get something to help eliminate cos x. Therefore, that's what we're going to sub. Sub u in for sine x. If you're not understanding quite yet, just follow along. This is why it's called substitution, because you're subbing in something for another thing. So we're going to sub in u for the sine x. We're going to derive it, get du with respect to x equals derivative of sine x is cos x. And now we want dx on its own because we have a dx up here. Because this integrand signifies we're trying to find the integral. This dx is multiplied onto this. It's anything between the dx and the integrand is what we're trying to find the integral of. But this dx is multiplied on. We can use this dx. We can't really use this. So we have a dx down here. We have a dx up here. This dx is on its own. Therefore, if we get this dx on its own, it'll help us solve it. So I'm going to have the du, that stays there. I'm going to divide the cos down, which brings it on the other side, and I'm going to multiply the dx up, which will bring it on the other side. Now we have dx on its own. So if we rewrite this, we get the integral cos x multiplied by ln of u, because remember we subbed in u for sine x. And instead of dx, we're going to sub in what dx is the same as. So we're going to sub in the du over cos x multiplied on. Now, if you look here, we have a cos x multiplied on, and we have it divided by cos x as well. So these cos x will be cancelled out, because cos x over cos x is 1, so they cancel out. Now what we're left with is just the ln of u du, which will look like okay. Now the integral, we said the integral of ln of x is x multiplied by ln of x minus x plus c. X is just the variable, our variable is u, so it'll be u multiplied by ln of u minus u plus c. Now, just like how we subbed in u for sine x, we're going to sub sine x back in for u. So we'll have sine x multiplied by ln of sine x minus sine x plus c. Now, with these two here, they're both multiplied. They have sine x multiplied in. There's a sine x multiplied onto the ln, and there's a sine x multiplied onto a negative 1. So if we factor them out, we get something that looks like this. Sine x bracket ln sine x minus 1 plus c. Because if we were to expand these brackets, we would get this. This is just a simplified version. Okay? And that there is your derivative of cos ln sine x. Let's do our second example. Second example, we have our function, and it equals 1 over x ln multiplied by ln of ln of x. Okay. Now, if we were to derive this, will we get something similar or something to help us get rid of that? The answer is yes. If you can't see it, that's fine. Practice. But first, because it's a function times a function, and we can derive something, if we derive something, we can eliminate something, then we use substitution. So, we find the integral of both sides, capital F, and the integral of this side will look like this. Okey-dokey. Now we do our substitution. We sub u in for ln of x. Now if we derive ln of x, we get 1 over x. Now this is the same as that. We won't be able to eliminate it, but just like before, we're going to try and isolate dx on its own. So we have du, we multiply dx up, and because it's 1 over x, it's already on the bottom. So the way to get it on this side would be to multiply it up. So we'd end up with x du equals dx. Okay, I'll show you why that's good news. So we have our integral. Now, integrand 1 over x ln of u, because we replace ln of x for u, and now we're replacing dx with x du because it equals dx. You see where this is going? We have a 1 over x, and then we have an x, and they're multiplied because they're all multiplied together. Therefore, we can get rid of the 1 over x, and we can get rid of the x because they cancel each other out. Okay, now we're left with just the integral of ln of u du. Just like before, the integral u ln of u minus u plus c. Okay, now we want to sub back in whatever u is. Now we said u was ln of x, so we're going to sub that back in now. So we have ln of x multiplied by ln of x minus ln of x plus c. Just like before, because we have an ln multiplied by a 1 and an ln multiplied by an ln of x, then we can factor the ln of x out. And there's a lot of ln of x's going on here, but that's why we're going to simplify it, or attempt to. And that there is the integral of 1 over x multiplied by ln of x. Thanks for watching. I hope you learnt something and have a good day.